Thank you. Hello, everyone. My name is Arundeep Saini, and today we'll be presenting our research of a structural analysis and design of LEED certified residential building. Today, I have with me Jocelyn Quintanilla and David Paiva as speakers, and Jocelyn will be beginning for an introduction.
So in our building design project, we were able to design with approaches using our civil engineering curriculum, some of our members' work experience using design softwares, and looking into building codes to design, and also using our interpersonal skills to work together as a team of undergraduate diverse students, including women in engineering, first-generation scholars, and multicultural backgrounds. So we were given building design requirements with an implementation of environmental friendly features. Here are our building parameters. Our design requirements were a 3-story building that was a steel structure consisting of moment resisting frame with 2,000 to 3,000 square feet for each story. We had to implement features that will get us LEED certification. And our categories for design, we went into doing beam design, column design, the way these were connected, the foundation, and checking for the seismic calculations, and our green building features to get to our certification, and then evaluating all these features that will be implemented in a cost analysis. So here is the significance of a LEED residential building. LEED stands for Leadership in Energy and Environmental Design. This study is necessary because, this feature implementing into a residential building, it has an impact on the environment. It will reduce waste, water and energy conservation, which is important. Right now with the California water conservation is crucial from the drought of water we have. And then this also provides a health inside health for the people who will be in this building. And it'll also have an annual cost savings. The LEED cost over the conventional building will be evaluated later on in our presentation. Here's our architectural plan. The area of each floor came out to be 3,096 square feet, consisting of 3 bedrooms, 3.5 bathrooms, with an open living and dining room area. Here's the 3D model of the architectural floor plan. You can see the 3 bedrooms on the lower left, the 3.5 bathrooms on the upper, and the open living room and kitchen area. Here's the north elevation plan of our building. It would be one of the sides. The south elevation plan, this would be the other side of the building. Here's the east elevation plan. This will be the front main entry of the building. And here will be the west elevation plan, which will be the rear of the building.
Hello, and then after the architectural floor plan has been designed and also approved by the owner, next we need to do is to design the structural skeleton of the building. So items that to be considered are, of course, the floor plan, also where windows and walls and doors are located. We also need to indicate and also determine the gravity loads on the actual building. So what we did, we took a top-down approach. First, we had to specify the material selections of the building. So we started at the roof at the top right corner. You can see we determined the dead load and of the building at the roof level, the ceiling level, the floor level, because these are the actual gravity loads that are going to be on the building at all times, essentially. So these are called dead loads, is the material selection. Then live load is based on the occupancy of the building. So because this is residential, we incorporated residential live load factors. Here you can see the roof framing plan. We used a grid to lay out the beams, which are supporting the roof joists, and also columns which are supporting the beams. Next slide, please. Next slide, you'll see the floor framing plan, which is very similar to the roof plan. We wanted to keep the columns all located in the same location. and the beams as well. That way it could just be a unison floor plan, I mean structural plan all the way from the top to the bottom. On the right, you can see how the beams are actually going to be connected to the ceiling joist. And for example, at the roof, the ceiling joist, the joist will be carrying the roofing material and all of the factors that we're going to be incorporating into our building at the roof level, and also at the floor level as well. The joists are going to be carrying the floor material, which could be either, in our particular building, it's actually going to be a concrete slab on top of it, and then on top of it is going to be a wood finish. So we check the sizes of these members, based on the deflection and the bending stress, to make sure that they are adequate for this type of occupancy. Next slide, please. Next, since all of the beams are carrying joists and something needs to be carrying the beams, you can't just have the beams, just hanging in free space. We actually incorporated a vertical columns to the building to make sure that everything is supported, and from the roof all the way down to the slab, which is called on grade. And what's supporting the columns at the slab level is going to be a pad footing. And also on the exterior, we're adding a continuous footing around the building to support the exterior walls and the interior walls as well. And we added like I said, a pad footing detail on the right-hand side, showing the connection between the steel to concrete pad footing. Next slide, please. Next, after we've determined, where the sizes, the locations of the beams and the columns are going to go, we needed to implement it into a design software called RAM, which is a 3D modeling software where you input your grid of the building, and you import your design loads and also your design requirements as far as deflection and bending stress. And for the beam design and column design, we use ASCE 716. For the foundation, we use ACI 318. And at the bottom left corner, you can see all of our design selections for beams, columns, and footings. After we designed all of the gravity members of the building, next we needed to also design for the seismic or lateral support, lateral resistance of the building, because the building is not only going to have all of the gravity weight on it, it's also going to experience natural forces such as earthquakes and wind. Next slide, please.
For our seismic calculations, we have went ahead and used a equivalent lateral force procedure to calculate story shear. Given that we have 3 levels, our total sum of story shear given out to be 337 kips. As shown below, you can see a base shear diagram. Using ASCE 716 in chapters 11 and 12, we were able to achieve this. And we classified the soil composition beneath the building as indicated as site class D. For our design and sustainability and LEED certification, we wanted to use a variety of LEED features, such as rainwater catchment, efficient plumbing, solar panels, LED type lighting for ambient light, thermal reflecting windows for better temperature control, and with the inclusion of tile floors, and energy efficiency. Provided here is our LEED certification checklist, which is provided by the LEED Programs Institute. We wanted to include access to quality transit for local and location and transportation for bicycle facilities, green vehicles, sustainable sites such as open spaces, rainwater management, water efficiency such as water metering and outdoor water uses, and rainwater catchment, energy and atmosphere controls such as renewable energy production, green power and carbon offsets, indoor, and also the inclusion of indoor environmental quality such as low emitting materials, interior lighting, and with the inclusion of daylight. Our total points came out to be 69, giving us a gold standard certification. With LEED features, there was also a percent increase in real estate costs to about 11% over the conventional cost. As we implemented LEED features, we have made a drastic change in total operating costs, where it have been deducted from $20,000 per year to $4,000 per year, giving us a time return on an investment in about 12 years. In conclusion, LEED is a green building certification program that recognizes best-in-class strategies and practices in key areas of human environmental health. The future of LEED will allow for drastically lower operating costs in exchange for higher quality of life. The student scholar models will allow and share, acquire new knowledges, ethical and professional responsibilities for years to come. Thank you.
We have a couple, so we finished a little bit early. We have, any of the judges have any questions for this group?
Yes, I do have a question. We're using a steel building for, moment frames and everything. It's a 3-story building. Did you consider to design this with wood construction? I mean, you can get a lot of shear walls and everything, and maybe construction costs might be a little bit lower to use wood.
When we did consider other types such as concrete and wood, but we found that steel moment connections have been very optimal in during seismic situations using stationary moment frames. And with the provided that steel would be ideal in many load and case factors. If we made the building out of wood, I believe it wouldn't handle as much dead load and live load given throughout the building. Though some parts of wood, just to reduce costs in terms of insulation and low emitting materials.
Okay.
I have a 2-part LEED question. That's okay. First part is, did you do any kind of analysis to compare LEED gold to just meeting Title 24 in California? And then the second part is, to ensure that you meet gold certification, did you consider, how to address LEED requirements during the construction process?
When we want to apply LEED features, we wanted to include as much as we could into what we had in our design. There was no restriction in terms of what we wanted to include. We wanted to make sure that we had where the LEED features would include water efficiency and drastic operating costs with a minimal increase in real estate values, since it will give us a greater return on investment and higher quality of life.
Right, but design is one way to meet, but then to ensure that you get that certification, there are things to do during construction to make sure you don't lose points.
Yeah, like the HERS rating. Yeah, we did incorporate that as far as in the analysis and the code analysis. I mean the cost analysis, because we kind of incorporated the cost for construction, which also includes different various inspections, which we know that are not only city inspections but also HERS raters and Title 24 raters. Because during the construction, HERS rater comes in and checks that we make sure that we install the proper windows and the proper insulation throughout the building. And they also check the HVAC system as well.
Thanks.
Thank you.
Any other questions from the judges? We have 2 questions from the audience. First question is, how could you have achieved platinum level? Would it be feasible?
For achieving platinum level, there was a certain certification cost to how much our building, our conventional cost would be. In terms of platinum level, we couldn't really achieve, given that there was a certain area restriction for other features to provide. With our checklist, we've made marks on what features we can include with the given square footage that we have for the building. So we were restricted to about silver and gold certification to include in the for the building.
Thank you. There's one more question from the audience. What is the largest size moment frame components, both columns and beam, you used? And is this an ordinary moment frame?
So this is actually not an ordinary moment frame. It is actually shown in the California standards that we must, ordinary moment frames are prohibited to be used. So we will use special moment frames for our building design. And we can show, as shown over here, for our structural design, the largest beam we have used was W18 by 35 for our beams. And for our columns, we use W12 by 40, which was indicated at the where we place the W12 by 40s on beneath the buildings for the very foundation that is connected to the columns. And the W18 by 35 is placed on the first floor of the building to handle a greater amount of weight.
All right, thank you. Any other questions from the judges or audience members? Okay, so we have about, oh, there's one more question. This will make your floor very large. It's not so much a question. I guess it was, so this will make your floor very large, the W18. Any response to that?
We did the modeling on RAM, and we did for our using the 3D model of the RAM structural design. And as we implemented our floor framing and ran an analyzation of the building, it actually gave us the advice to use W18 by 35 for one of the floors. And since it's a heavier material to handle more load, we suggested that we put it in the first floor.
All right, thank you so much. Thank you to the structural analysis and design of a LEED building group. Thank you, judges and audience, for your questions.